remainder of the unreacted A and 1% of B entering the reactor. So you are supposed to calculate the single pass conversion of A in the reactor as well as the mole ratio of recycle to feed. So let's see how we can solve this kind of problem. It's a very important kind of problem. Here you can learn two different concepts. So this one is the reactor and this one is the separator and this one is the product stream. So here this one is the feed and one stream is getting recycled back, right? So in recycle stream, let's say if I am talking about, so here only A and B is there, and this product you can see there is A and B and C will be there. Since the reaction is happening like reaction is your A is getting converted into 2B plus C, means if 1 moles of A is getting converted, 2 moles of B and 1 mole of C is getting formed, right? These things is very important to understand here. Now let's try to focus on the data. So overall conversion is your 95%. So let's say only feed is only pure A, right? So if I'm starting with 100 moles of A, 100 moles of A, is that clear? So here 95% overall conversion of A is there, right? So how much A is getting how much A will be remaining at the exit of the reactor here? So A will be equals to 95% is getting converted. So 95 moles will get converted. So here you will see 5 moles of A will be there. Is that clear? So we have two things right now. So we have total moles of A at the entrance of the reactor and in the feed, and total moles of A at in the product, right? Now one thing is that you can understand the product stream from the separator consists of B, C and 0.5% of A entering to the separator. So the number of, let's say if I am assuming this one is the 0.1, this one is the 0.2, and let's say this one is the 0.3. Is that clear? So number of moles of A at 0.3, which is equals to 0.5% of number of moles of A at 0.2, right? So we want to calculate number of moles of A at 0.2, that is equals to number of moles of A at 0.1 divided by 0.5 and multiplied with 100 you can write. Okay, so number of moles of A at 0.2 can be written as how much at 0.3, this is 5 multiplied with 100 and divided by 0.5, so it will be 1000, right? So here you will see number of moles of A will be equals to 1000. Is that clear? 1000. Now just try to imagine one thing. The number of moles of A which is entering into the separator will be equals to number of moles of A at 0.3 plus number of moles of A in reactor. So what I can write here, number of moles of A at 0.2 is equals to number of moles of A in the recycle stream plus number of moles of A at 0.3. So we know this one is your 1000, that is equals to number of moles of A in the recycle we don't know, plus number of moles of A here is 5. So number of moles of A in the recycle stream, that is equals to 995. This is very important. So we get to know this thing, that number of moles of A in the recycle. So here Na is equals to 995, first thing. Second thing is that now you can understand one thing, 100 mole is coming, 995 mole is coming here. So how much number of moles of A at 0.1, that is equals to 100 plus 995. So number of moles of A at 0.1 is equals to 100 plus 995. Is that clear? So that will be equals to 1095 moles. So number of moles of A. Okay, so now what you can see, this one is the reactor. Let's try to understand. Number of moles of A here is 1095 and number of moles of A at the exit is equals to 1000. Is that clear? So what is single pass conversion? XP, that is equals to number of moles of at the entrance of the reactor minus number of moles at the exit of the reactor divided by number of moles at the entrance of the reactor. Is that clear? So this one is the single pass conversion. So if you do these things, you will be getting 8.675%. Okay, so your question is clear now, I hope. Okay, so this is how we can solve this single pass conversion for this particular problem. Now you are supposed to calculate what is mole ratio of recycle to feed. So feed is your 100 moles and what is recycle? So in recycle we have A and we have B. So we have calculated number of moles of A, and if we are able to calculate number of moles of B, we will be able to calculate the recycle. But here you can see there is one point. While the recycle stream consists of the remainder of unreacted A and 1% of B entering the separator. Is that clear? So let's try to understand how we can calculate the moles of B which is entering to the reactor. So moles of B which is getting formed in the reactor. So if you see the reaction is happening, A is getting converted into 2B plus C, right? So here what you can see that for 1 mole of A, 2 moles of B is getting formed, right? So here number of moles of A is 1095, and here number of moles of A coming out of the reactor is 1000, means 95 moles of A is getting converted, right? So how much number of moles of B is getting formed? So number of moles of B will be equals to 2 multiplied with 95, 190. So 190 moles of B is getting formed at the exit of the reactor. So here you will see that number of moles of B, here you will see that is your this thing, number of moles of B. Now the total number of moles of B which is getting formed is equals to how much? We are getting 190, and out of that only 1% of B is entering to the separator, right? So if you see that how much number of moles of B you will be getting here, that is 1% only. So that is your 1.9 moles. Is that clear? Okay, sorry, only 1% of B entering to the separator, means here it will be number of moles of B will be 1.9, right? So total number of moles of B is 1.9 in the recycle, number of moles of B in recycle is 1.9, and number of moles of A in recycle that we have already calculated, that is 995. Just 1 second, let me drag this. So what is total recycle stream? Recycle stream is number of moles of A in the recycle stream plus obviously number of moles of B in the recycle stream. So that is equals to your 995 plus 1.9. So that is equals to 996.9 moles. So what is the feed divided by recycle ratio? Oh sorry, you are supposed to calculate R by F. So recycle divided by feed, that is equals to 996.9 divided by 100, that is equals to 9.967, which is equals to 9.97. Is that clear? So this one is the final answer of question B. Is that clear? So you are supposed to calculate these two things. I hope this is clear to all of you. And after that we'll move forward towards the next problem. Okay, and the next problem